In 1957, a 26-year-old physicist named Hugh Everett III walked into the office of his doctoral advisor at Princeton University and quietly placed a thesis on the desk. The thesis did not propose a new particle. It did not describe a new force. What it described was something far more unsettling. A universe in which every possible outcome of every quantum event actually happens, simultaneously, in branching, parallel copies of reality. His advisor, John Archibald Wheeler, reportedly spent weeks trying to soften the implications before letting Everett publish. He was right to hesitate, because if Everett was correct, and a growing number of physicists believe he was, then tucked inside his mathematics is a consequence so strange, so personally confronting, that most textbooks quietly skip over it. A consequence that concerns not the cosmos, not abstract particles, but you. Specifically, what happens to you when you die? By the time we reach the end of this, we will have done our best to trace that consequence all the way to its logical edge, and then decide together what to do with what we find there. Let us be precise about what we are actually talking about. Quantum immortality is not a metaphor. It is not a spiritual claim. It is a strict logical implication that follows from one of the most mathematically rigorous and empirically consistent interpretations of quantum mechanics ever formulated, the many worlds interpretation, or MWI. The core claim is this: in any situation where quantum mechanics allows for multiple outcomes, all of those outcomes occur, each in its own branching version of reality. No single outcome is selected. No wave function collapses. The universe simply forks. Now here is where it gets personal. Consciousness, your continuous first-person experience of being alive, can only ever find itself in branches where it continues to exist. You cannot experience your own absence. You cannot be present for your own non-presence. This sounds almost trivially obvious when I say it aloud. But follow that logic wherever it goes, and you arrive somewhere deeply uncomfortable. If the universe is always branching, and if there is always some branch, however improbable, in which you survive, then from your subjective point of view, survival is not merely possible. It is, in a specific and technical sense, inevitable. That is the claim. Let us now take it apart carefully. To understand why this idea has any traction at all, we need to go back roughly 300 years before Everett, to a philosopher who was, in his own way, equally obsessed with the problem of the observer. Gottfried Wilhelm Leibniz, writing in the 1710s, proposed that the universe is composed not of matter, but of monads, indivisible, experiential units, each of which contains within itself a complete perspective on reality. What matters for us is not the metaphysics, but the logical move Leibniz was making. He was insisting that the universe, at its most fundamental level, cannot be understood without accounting for the point of view of the thing doing the experiencing. Physics spent the next 2.5 centuries trying to prove him wrong. It built a magnificent edifice of third-person, observer-independent laws. And then quantum mechanics arrived, and the measurement problem arrived with it. And suddenly the question of what counts as an observer, what it means to be the thing that experiences an outcome, became the most contested and consequential question in all of Foundation's physics. Everett's answer was radical. There is no special observer. Every branch is equally real. But what that means for the being who is doing the experiencing, for the first-person perspective, is something Everett himself did not fully work out. That gap is where quantum immortality lives. In 1987, AI researcher Hans Moravec formalized thought experiments about personal identity across branching possibilities that physicists had been quietly circulating for years. Let us construct a clean version. Imagine a machine. The machine measures a quantum event, the spin of a single electron, which quantum mechanics tells us is genuinely, irreducibly random, with a 50-50 probability of being spin up or spin down. If the electron is spin up, the machine does nothing. Life continues. If the electron is spin down, the machine emits a signal that ends the experiment. Now run this experiment 10 times in sequence. In a classical single universe world, the probability of surviving all 10 rounds, never triggering the signal, is 1 in 1024. Unlikely, but not impossible. In a many worlds universe, something different is happening. At each step, the universe branches. In one branch, the signal sounds and the experiment ends. In the other, it does not. After 10 rounds, there exists a branch, a genuine physical branch of reality, not a fiction, in which the machine has never triggered. Once. From the outside, from a third-person perspective, this branch is extraordinarily rare. From the inside, from the point of view of the person in that branch, it is the only branch that has ever existed. They have simply sat through 10 coin flips and gotten lucky 10 times in a row. Nothing feels miraculous. Nothing feels strange. This is the sleight of hand at the heart of quantum immortality. The strangeness is invisible from the inside. Here is where we need to be honest about the structure of the argument, because this is where it becomes genuinely difficult to evaluate. Quantum immortality relies on what physicists and philosophers call an anthropic selection effect, sometimes formalized as the observation selection effect, described by Swedish philosopher Nick Bostrom in his 2002 monograph, Anthropic Bias. The argument runs like this. We can only ever observe the universe from a position within it. We can only gather evidence from branches where we exist to gather evidence. This is not a bias we can correct for. It is a structural feature of what it means to be an observer. You have already survived every single thing that has ever threatened your life, up to and including this moment. Every near miss, every statistical fluke, every close call you have never even known about. From a classical perspective, this is just luck, accumulated over a lifetime. From an anthropic perspective, it is tautological. Of course, you have survived everything so far, because if you had not, there would be no you to sit here and reflect on it. Now, here's the unsettling second turn. If many worlds is correct, then that tautology does not merely describe your past. It describes your future. There will always be some branch where you continue. And your first-person experience, by definition, by the geometry of what a first-person experience is, can only ever find itself in those branches. The universe does not protect you. It does not care about you. It simply branches, indifferently, endlessly. And in the accounting that results, something that looks, from the inside, disturbingly like immortality, is an arithmetical inevitability. At this point, a reasonable objection assembles itself almost automatically. You might think, this is just the gambler's fallacy wearing a lab coat. The electron does not know about my previous runs. Each branch is independent. Surviving 10 rounds does not change the odds of the 11th. And you would be absolutely right about the physics. But that objection, however valid, is aimed at the wrong target. Quantum immortality does not claim that the odds change. It claims that the only branches you can ever experience are the ones where you are there to experience them. You are not beating the odds. You are simply, always, structurally, located in the branches where the odds have gone in your favor. Not because you are special, because the others are not accessible to you. The real objection is harder. It is this. What exactly counts as you continuing? If every quantum event branches the universe, then the version of you that wakes up tomorrow is not the same version that went to sleep tonight in every other branch. In one branch, you dream about something and wake up slightly changed. In another, a single neuron fires differently, and your first thought is entirely different. Which one is you? This is the question that has consumed philosophers of personal identity for decades, and it does not have a clean answer. Derek Parfit, in his 1984 work, Reasons and Persons, argued that personal identity is not what matters, that what we call the self is a convenient fiction layered over a continuous process of change. If Parfit is right, and the argument is formidable, then the very premise of quantum immortality, the survival of a continuous self across branches, becomes philosophically suspect. But here is the catch. It becomes suspect for regular mortality too. The self that fears death may not be continuous enough to be the same self that dies. We have not resolved anything. We have only moved the mystery one level deeper. In Peter Burns' account of Everett's life and private papers, one conviction runs through everything Everett wrote and said. The wave function does not collapse into one history. It unfolds into all of them. Take a moment with that. He was not describing a convenient mathematical formalism. He believed it. He believed all of it was real. Every branch, every copy, every version of every outcome. And he died at 51 in 1982. By his own reckoning, in most branches of the universe, Hugh Everett continued. In the branch we inhabit, he did not. Or rather, in this branch, we cannot find him. The most technically grounded objection to all of this comes not from philosophy, but from physics itself, and it deserves to be taken seriously. Quantum superposition, the condition in which a particle exists in multiple states simultaneously, is extraordinarily fragile. The moment a quantum system interacts with its environment, the superposition unravels through a process called decoherence. The branches become, for all practical purposes, mutually inaccessible. They do not interfere. They do not communicate. They evolve in total isolation from one another. For decades, this was presented as reassuring. Decoherence explains why we do not see quantum weirdness at the scale of everyday objects. It explains why a coffee cup is simply there on the table, not smeared across 1,000 possible positions. It is the mechanism that makes the classical world emerge from the quantum substrate. Here is the problem. Decoherence does not eliminate the other branches. It merely makes them inaccessible to us. The physics of many worlds, taken seriously, says those branches are real, regardless of whether we can reach them. Decoherence tells us we will never experience a universe where the electron was both spin up and spin down from our vantage point. It does not tell us that the other branch does not exist, which means the very mechanism physicists use to make quantum mechanics sensible is, simultaneously, the mechanism that locks every version of you into exactly one branch, forever, unable to compare notes with all the other versions of you who survived different things, made different choices, and are, right now, having a completely different experience of what it means to be alive. We have been circling it the whole time, and we should name it directly. The measurement problem in quantum mechanics remains, today, one of the deepest and most genuinely unresolved questions in all of physics. When we observe a quantum system, what actually happens? Does the wave function collapse, as the standard Copenhagen interpretation asserts? And if so, what causes the collapse? And why is observation special? Or does the universe branch, as many worlds claims? And if so, what determines the structure of the branches? And what exactly counts as a valid point of view within them? These are not philosophical decorations on an otherwise solved theory. They are questions with physical consequences. The answer determines what quantum immortality means, or whether it means anything at all. If the Copenhagen interpretation is correct, if there is a genuine physical collapse, then many worlds is wrong. The branches do not exist, and quantum immortality is a category error dressed up in elegant mathematics. if many worlds is correct, and recent experimental work on the Wigner's friend thought experiment, explored in precise terms by Kaslow, Bruckner, and colleagues, is beginning to make the question empirically tractable in ways previously thought impossible. Then something like quantum immortality does follow from the mathematics, even if what exactly it implies for consciousness and personal identity remains genuinely, stubbornly unclear. We are not at a place where we can simply look up the answer. The physicists are still arguing. The philosophers are still arguing. And the question of what happens to you, specifically to the continuous thread of experience that you call yourself, remains open in a way that is not comfortable or provisional. It is open in the way that fundamental things are open. So here we are, 1957, a young physicist's quiet thesis, a mathematics that blooms outward into every possible reality. And somewhere in that blooming, if the mathematics is right, is a version of you that will never be present for its own ending. Not because it is special, not because the universe has conspired to protect it, but because presence, by definition, cannot attend its own absence. Because the accounting of first-person experience produces, as a strict arithmetical output, a being that always finds itself, against all sensible odds, still here. Is that immortality? It depends entirely on whether you think the other branches count as you, on whether personal identity is a thing that persists, or a story we tell ourselves about continuity, on whether the self is a substance or a process. Leibniz thought the answer was built into the architecture of reality. Parfit thought the question was malformed from the start. Everett thought the universe was too busy branching to care either way. We do not know who is right, and that ignorance is not a failure of science or philosophy. It is the most honest thing we can say about one of the oldest questions a mind has ever asked itself. The universe branches, indifferently, endlessly, and in every branch, something that has your memories looks out through your eyes and believes it is the only one. Maybe it is right. Maybe they all are.